Hello everyone, hope you are all doing good. So my name is Akhil. So I am going to present on a topic called governing Kubernetes cluster at scale with the help of auditing and policy enforcement. So let's understand what is governing Kubernetes cluster. So making the cluster compliant to the organization policy. So this is a single line of statement, right? And let's see why organization will keep policies for their Kubernetes cluster. So I will give you a short example of a fintech company, so which grown from small to big. So initial days of the company's establishment, so for running their microservices, so they have provisioned a 3-node Kubernetes cluster. It's a very small, and they have provisioned 5 microservices. So at that point of time, so they randomly deployed all the resources without following any best practices that needs to be done. That didn't happen exactly. So fine, everything is fine. The organization is also growing as well as the Kubernetes cluster is also growing. Like they need to scale up from 5 microservices to the 50 microservice with the 70 plus front ends, micro front ends. So then they observed a bit TDS as part of a Kubernetes cluster and inconsistency in their resources. So then they went to this FinOps part and they observed the cloud billing for the specific Kubernetes cluster they are using at a scale. So they observed on a month-on-month billing there is a 40 to 50% approximate jump that happened suddenly. So that is a very big, huge cost for a small fintech company which is having a couple of million users. So then what they decided is they want to dig down into the Kubernetes cluster and see what are the challenges that they are facing. So then they got to know so there are many challenges that exactly happen. So there is over provision of the resources. So they are having around 50 to 70 microservices and micro frontends, but they provision for 200 plus microservices without any knowledge. So there is no proper standardization rules there. And also they are not following the proper structure. So there are more memory leaks in their applications. So they are not tracking it. And they are also not properly implemented their FinOps part. There are no proper labeling structure to their resources. So these are some of the best practices that they didn't implement in the small stage and they finally found out at the big level. So due to that, so there are so many memory leaks without identifying the exact challenge. So what exactly happened is the engineers who are working, who are managing the Kubernetes clusters that keep on scaling up, scaling up, scaling up. So without identifying the exact root cause. So that's the main challenge that they faced and their billing was increased a lot. Let's see what exactly happened and how we can reduce these kind of issues at a scale. With the help of, so I will be telling a solution with the auditing as well as the policy enforcement. Let's deep dive. So these are the contents what I'm going to cover as part of this presentation. So here there is a silent cluster drift. I will be explaining that. So here I choose 2 set of open source tools. One is like a Papaya, so the sanitizer, or you can also call it as the auditor on top of our cluster. Next is like I know the gatekeeper. This is the policy enforcement that we are using. And next we will go with the how these 2 tools works and follow up with the practical demonstration. So as I mentioned, so there is a huge complexity if you are not following the best practices at scale. There will be a silent cluster drift in these cases, as I already said, right? From small to the big without identifying the challenges. So here there is 3 major pillars of a cluster decay. So these conditions we call it as a cluster decay, and these are the key pillars of that. So one is like a resource inefficiency, like over provision of the resources without identifying the exact problem, unused secret, dead namespaces which are not used. So these are a couple of examples. There are many of the things that comes under resource inefficiency. And there is a security vulnerabilities as well. So container runtime, we are using it as a root. So it is giving anybody can go and open the terminal of the pod and can do anything to the code. So that is one more challenge. And also using the deprecated API versions of Kubernetes. So you should keep on upgrading the Kubernetes and that will keep our proper cluster in sync. Next is like consistency gap. So if you are not having any standard labels, so that will create a chaos in case of FinOps as well as the monitoring part. So due to this, we will have a reactive trap. So ultimately, so we are identifying the issue at a scale, and we are trying to resolve that, which is costing us on FinOps level as well as the efficiency level. Now let's see how exactly this Papaya and Caverno will work together, and we'll see. So this Papaya is like open source read-only utilities, which runs outside of your Kubernetes cluster. What exactly it is like? It's very simple. So it will scan your cluster and give you the report. In the report, you can see what are the resources which are not following the best practices. Next, Caverno. So we can, as we already said, this is a gatekeeper, and the policy enforcement we can do with the help of Caverno. So this is running as part of a Kubernetes cluster. So how it is running? So we will be creating Caverno as an operator, and a couple of CRDs are installed as part of this. So this will control the policy creation. And so Caverno will do three kinds of things. So one is like validate, based upon the policy that we have created. Whenever the incoming creation request comes to the cluster, so it will validate with the policy. If that is properly applied according to the policy that we have kept, it will allow, or else it will reject. Then it is a mutate. Let's say, that's an example. Let's say we are creating a pod or a deployment, and without resource limits and requests. So we can enforce them directly. So we are not stopping them. So we are allowing them to create into the cluster. By default, we are adding the default resource request and limits and generate. Let's take an example, like we are creating a deployment as well as a service to expose the deployments, right? So for that, we need to have communication controls with the help of our network policies. So with the help of the generate, we can by default create a network policy whenever the service got created. So these are the things that Caverno can do. And let's see how the flow of this Papaya CLI tool works. So one is like a CLI, as this is running outside the cluster. So we can also integrate this as part of a CI/CD pipeline for continuous auditing purpose. And what exactly it will do is that it will read the context and the credential with the help of the kube configuration file or the Kubernetes cluster. Once it was authenticated to the cluster, so it will contact to the kube API server, and it will get all the details of the resources in the cluster. And one more thing, what it will do is it will also contact to the metric server. So if you guys don't know about the metric server, it's a simple service which is running as part of the kube system namespace. It will keep on monitoring the resources and provides the resources like the CPU and the memory usage. So it will also get those resource utilization of all these resources that are running as part of cluster. So with that, what it will do is like it will calculate what are the resources which are under provision and what are the resources which are over provision. So with that, we can exactly adjust all these things. And next, once it gets all the details, so by default, Papaya will have a linter rules. So it will calculate all the information that it has with the linter rules, and it will generate a proper report. So here the reporting structure we can export in a different way. So one is like in a CLI itself you can see the report. One is like HTML, and one more is the Prometheus matrix. You can create a dashboards and you can export them. And one more thing is like a JSON query. So this is how Papaya works. And let's see the Caverno architecture. So this is the API server that we already know that will be sitting in the Kubernetes cluster, and this is the main component. So whatever the request we are doing, like creation request or updation or modification, whatever it is. So first it will talk to the kube server. So once we install Caverno this particular the whole tool set, so it will install two components. One is like Caverno webhook, and one more is the server. So here, if you see the server component, so there is three set of rules. Like one is the policy, generate, and background. So once the request, like a creation request or modification come to the server, so it will invoke this Caverno webhook, and that webhook will send that request to this server. So this policy layer, so will contain all the policies that we have created. So it will do a validation, mutation, or all these things will be happened at this policy layer. Next is the generation layer. So as I mentioned, the third part that Caverno can do is like the generation part. So those generation activities will be taken care by this layer. And one more is like a background. So even though all resources are created as part of this cluster, it will keep on checking. It's like a continuous loop if there are any issues or not. So it will keep on repeating all these things. So that's how this proper architecture works. And next we will go to the practical demonstration. So here I already created a repository with all the documentation and the manifest file that I will show you. And we'll open this. Yeah, so this is the repository. So we'll directly jump into the README file that I already created. Yeah. So this is the demonstration flow. First, we will be creating a kind cluster. So kind is a tool where we can create a local cluster, local Kubernetes cluster. So for the simplified version, so I am choosing it. So you can also have this repository and you can just practice all these things. Next, what we are doing is like we are intentionally deploying the bad workloads in the Kubernetes. So what is the bad workloads? We'll see what exactly contains as part of the bad workloads. Then we'll do a scanning the cluster and find all the problems with the help of the Papaya CLI. Next, we will install the Kavanaugh and apply the policies. So based upon the result that we are seeing in the previous phase. Then we will try to deploy the same bad workload. Now, after installing the policies, you should not allow the bad workloads to be installed into the Kubernetes. Next, we will see whatever the bad workloads we see, so we will be fixing it and we will make it as a good workloads. And then we will try to rescan with the Papaya. Again, we will see the TNR report now. It should not show any issues. And at the last, we will also see the mutation policy as well, how the mutation works. So above all these, up to 6th step, we are going to look at, we are going to see about the validation. The 7th step, we will see about the mutation, how it exactly works. And the prerequisites is, these are the things. So I already given the links, so you can go and install if you are not having. And this is the project structure. And this is a step-by-step demonstration. So as part of this demonstration, I already created the kind cluster as part of my local setup. So this is what I have done. So this is done, and we'll quickly go with the flow. And we'll see this one, if everything is up and running or not. Perfect. So I just created a single node cluster. So it's a control plane. And now we will deploy the bad workloads. First, we will create a namespace, and we will name it as audit enforce, and then we will create these bad workloads. Okay, so in the meantime, we will see what exactly the resources are part of our bad workloads. Yeah, here if you see, I'm going to create 3 deployments. So one is like the bad Nginx. It doesn't have the proper labels on a deployment. You can see here I'm highlighting this. And one more thing is like it is missing the standard labels. So here what I'm trying to do is like, so here I'm trying to make app and the team label are mandatory for whatever the resources that are getting created. So those are missing. And here also the container is using the latest image type. So ultimately I think you are already aware you should not use the latest. So latest is keep on upgrading. So without knowing what additional features are added to the latest, we should not use. We should use based upon requirement, we should pick the version and we should use it. And then there is no request limits, probes are not there, security context is also not there. So that's the same I'm doing with the next set of deployments with the bad Redis. So all these things are not there, and also with the bad busy box. So here also we are not having the proper latest test and no resources and probes. So these are the resources just now I have created. So we'll go back and we'll see. So these are up and running. Perfect, these are running. And now we will do a Papaya CLI scan and identify what are the things that are not properly following the best practices. Yeah, so this is the scan command. And if you see the cluster health here, based upon the scanning, it has given the score for a cluster. So this is a 89% healthy. And see why it is just 89, why it's not 100%. Yeah, if you see, these are the issues that are part of the cluster. And we'll go with the deployments. Here in the deployments, as we already discussed as part of bad workloads. So we are we are using the latest image, and we are not having the resource request and limits. So that's the same for all these 3 workloads. And we'll also see on a pod level. See on a pod level what it identifies like, it doesn't have the network policies, it doesn't have the pod description budgets, and it is using default service account. Ultimately, we should not use a default service account. We should create a service account with a proper set of permissions. So that's how we will be restricting it. And next, the same thing. If you see the security context level, so it is running, the containers are running as a root user. So that is a very danger. So these are the things that Popeye has identified. Now what we will do is like, based upon this report, we will create the policies and we will apply this policy, and again we will apply this same bad workload and see if it is allowed or not. Let's do that. Yeah, as I said, we can also export this report as a HTML that we can do, but for a time being I am not doing that. And let's install the Caverno here. So I am using Helm open source repository. What exactly it will do is like, it will create the Caverno operator and the some set of CRDs. Done, and we will be installing it. I just updated my Helm repository to get the latest Caverno version. Yeah, fine. So this will take a couple of seconds, and we'll do a wait condition. Yeah, so this will be getting created. In the meantime, we'll see the policy. What exactly are there as part of the policy file. So this is the policy manifest. So if you can see, so I have created a cluster policy. One is for disallow latest tag. So after applying this policy, it will not allow any resources which are having a latest tag. So if you see the specs, so these are the resources that this policy will be applied: deployment, stateful set, and daemon set. And next is like a validate. So we are giving a pattern here. So this is how we will be defining in the cluster. So based upon that, we will using the regular expressions, and we are identifying how this is happening. This is how we are caching the exact validation level. The same for we are also creating for resource limits, and if you can see, so this is how we will be creating as part of a deployment manifest file, and we are using the regular expressions here. So and also I have done the same for probes, you can see here, and also for running as non-root users. So I am checking for a security context here. This is the one. And this is for required labels. As I mentioned, like, so there are two labels that I am asking as a mandatory thing. One is like an app and a team. So this is the validation rule. And next, this is for default resources, for resource request and limits. Okay, so exactly what this cluster policy will do is like, it will do a mutation one. So we will do this at the last. First we will complete this validation level. Yeah, now all our Caverno workloads were installed and were up and running. And we'll go back. Now what we will do is like, we will again apply these bad workloads. So before that, what I will do is like, I will delete this because we have already installed it. Delete it, and we will apply the policy here. So these are all policies. This Caverno has been installed, right? So we will be applying the policies now. So whatever the policies that we have seen as part of the manifest file, all are created now. And now we will list the cluster policies that we have created. Perfect. All of them are up and running, and they are ready. Now we will try to apply the bad workloads. Now ultimately what it should do, it should block us, and it should show us the error message why it is blocking. Perfect. Here you can see the exact error message. So based upon what it has doing is that we are trying to create a bad workload. It is doing the validation with all the policies that we have created, and it is displaying the error message. So this error message also we can design as part of a policy. So again we are seeing like a disallow latest tag. So that is not there, and we are required labels. The labels are not there. Probes, limits, and security context. So that's the same happening for all the three workloads that I have created. Now what we will do is like, we will deploy, so what we will do is like, we will deploy the good workloads by rectifying all these issues. Here what I will do is, I will go back and open the good workloads. And first what we will do is like, we will apply, it will take a couple of seconds. Yeah. And now we'll see what exactly this contains. So here whatever the issues that Papaya highlighted, here I am rectifying those things. And if you see here, so I am creating a service account, specific service account, and we are not using a default service account for a security purpose. And next, we are creating the good Nginx, and we are having the required labels, security context, dedicated service account, and we are also using a specific Nginx version, not latest, and we are also having the resource request and limits and probes for a health check. So that's the same thing happening for other two workloads that we have seen. So if you see, I have highlighted whatever we are adding and whatever things which are required. Perfect. And we'll see, we'll go back and see if those are up and running. Perfect. All of them are up and running, and we'll see the report now. Yeah, this mutation part I will go after showing you the report. First, let me scan it with Papaya. Yeah, if you can see the score, previously we have seen the score of the cluster is 89%. Now it is 100% because we have rectified all these things by creating our policies, and we are enforcing it to not create without any, without not having any best practices. You can see the pod level, we are having everything, and on a deployment level, also we are having everything. So it is not highlighting any issues after applying the policies. So this is how the validation works with the help of Papaya and Kavarno. And let's do a mutation one. It's a very small demo. We'll quickly do it. So there is one workload I have created, like it's just a pod creation. I will open it and I will show you what exactly this contains. Let's open it. Yeah, this is a test mutate. And I'm just creating a very small pod. And here if you see as part of pod, we are not defining any resource definition. So we are not having any request. So let it create and see. Okay, before that, we'll see the policy, what exactly this policy will do. We'll go to the last, and this is the last policy. Yeah, so this is a mutate policy. As part of this, we are adding a default resources. So the default resources we are adding for CPU, we are adding 100 M, and for memory we are adding a 128 MI. And we'll apply this and see if these are added or not. So as part of this manifest, we don't have this configuration, but the policy itself should add it. Perfect. This is created, and let's see. See, as part of the mutate policy, so these requests with the CPU and the memory that we have defined as part of a policy have been applied to this particular pod that we have created. Yeah, this is how we can control like the audit, and we can control the policy enforcement as well. Yeah, thank you, and I'm good with the questions. So if you are having any questions, we can discuss. Any questions? Any question from this side or this side? I hope you guys understood the exact concept and how we will be running a Kubernetes cluster at a scale. So this is very important when the cluster is growing big and big. The proper policy enforcement should be happen. If that is not there, as I said in the fintech example, this is a nightmare to the teams who are managing it. Thank you once again.